Okay, today we are going to find compound probabilities and identify overlapping events. Yesterday we talked about compound probability when they use the terminology and, or when they use the terminology or. Whenever we have an or event, I really need to think about is there a chance that there's overlap? And we'll work with some examples. So it says you have a standard number cube. Find each probability. So we're rolling a dice. What's going to happen? The first one says the probability that we roll an odd number or a number that is less than 4. So what I would do here is I would write out my outcomes. So rolling an odd number, what odd numbers are on that dice? It would be a 1, a 3, or a 5. The other one says a number that is less than 4. So the numbers that are less than 4 would be a 1, a 2, and a 3. Now what we talked about yesterday was we would say, well, there's 3 chances out of 6 to roll an odd number, or means I need to add them together. The chance that I roll a number less than 4, well, there's 3 of them, 3 out of 6. Well, when I add these together, I get 6 out of 6, which means there's a 100% chance that I'm either going to roll an odd number or a number less than 4. And if we think about that, that doesn't quite make sense because that means I could never roll a 6. Is that true? No, I could definitely get 6. So this is where we would have a case of overlap. When I look at the two number sets, what numbers do they have in common? Like I have a 1 and a 3 here. I also have a 1 and a 3 here. If you've ever used a Venn diagram before, what we could really think about is if I look at this first set of numbers, where would the overlap be? Well, we already said the 1 and the 3 overlap. I still have this 5 out here. Okay, the second set of numbers, the 1 and the 3 overlap, I have this 2 out here. So these are really my only outcomes, these 4 outcomes right here. Okay, what I need to think about when I have overlap is I subtract the numbers that are overlapping, or the outcomes that are overlapping. Okay, how many did they have in common? Well, 2 of them. So from this probability over here, I need to subtract 2, 6. What I've done is I've counted rolling a 1, I counted it as 2 separate outcomes. Or rolling a 3, I counted it as 2 separate outcomes. But it would really be the same thing occurring. Okay, so if I subtract these, I end up with 4, 6. And then we could change it to a decimal, which is where I get that 0.667. Okay. All right, so we'll try another one with overlap. The next one says, what's the probability that I roll an even number? So if I write out my evens, it would be a 2, a 4, and a 6, or a multiple of 3. Multiples of 3 mean like 3 times 1 gives me 3. 3 times 2 gives me 6. 3 times 3 would give me 9. 9's not on my standard number cube. I'm not going to put it there. Okay, so when I do my original calculation, over here I have 3 outcomes out of 6 possible. They did have an or event, so I would add them together. Here I would have 2 out of 6 chances of rolling a multiple of 3. Okay, this gives me a probability of 5, 6, but we said this is one that has overlap. What outcome is overlapping? Well, I see that this 6 right here. Okay, so I have one number out of the 6 that are overlapping. That gives me a probability of 6. So once again, I end up with approximately 0.667. It's not always going to come out to 0.667. All right, let's try another one. Suppose you have 7 index cards, each one having the following letters on it, A, B, C, D, E, F, G. It says, what's the probability of drawing an F, an A, a C, or an E? Okay, well, my probability would be 4 out of how many letters? 7. Okay, what's the probability of drawing a C, an A, or a B? Well, that would be 3 outcomes out of 7. Okay, here if I said FACE, that would be 4 out of 7. Or means I need to add them. CAB would be 3 out of 7. Remember, this is saying 100% chance that I draw those letters. That means that there's no chance I could draw a G out of that bag. That doesn't make sense. Okay, so how many are overlapping? Well, this A and the C are overlapping, and this A and C are overlapping, so I subtract 2 of the 7 outcomes. I end up with 5/7, which is going to be approximately, I got 0.714. All right, so that's dealing with overlap. We subtract the overlap. We only look for it when it says or. The last part we're going to cover for today is solving with compound probability. So this is using that compound probability from yesterday to find a missing piece. So using some algebra. It says you are throwing darts and rolling a die. You would like the combined probability of rolling a 3 and throwing a dart and hitting a green section to be 15%. How many green sections do you need on a dartboard of 10 equal sections? Okay, so there's two things that they're asking for to occur. Okay, they want the probability of rolling a 3, then it says and throwing a dart and hitting a green section. So two things, and it says and. Okay, my probability of rolling a 3 would be one outcome out of the 6 possible outcomes, and means we're going to multiply. Then it says the probability of throwing a dart and hitting a green section. What I know is that my dartboard has 10 equal sections, so my bottom number is going to be 10. But what's the top number going to be? How many green sections do we need? Well, it's an unknown, so we're going to put it as x here. Okay, on the other side, I know that my combined probability is 15%. So to write 15% as a decimal, I need to put it as 0.15. Okay, now think about this. How do we multiply fractions straight across? 1 times x gives me x. 6 times 10 gives me 60, and I'm going to set that equal to 0.15. Well, how would I get rid of that fraction? I need to multiply both sides by 60. The 60s cancel out. Now I'm going to have x is equal to, if I take 60 times 0.15, I end up with 9. So if I wanted to answer it, I would say I need 9 green sections is what it's asking for. And that would be a pretty funny looking dartboard. Okay, we'll try another one. Okay, you're spinning a spinner and you are rolling a standard number cube. The probability of spinning a red is 25%. What is the probability of spinning a red and rolling an odd number? Okay, well, the probability of spinning a red was 25%. I could write that as 1/4, 25%. I could also write it as 0.25. It doesn't matter. I'm going to choose the fraction for right now. So 1/4. And means I need to multiply. Rolling an odd number on my standard number cube. Well, that's going to be 3 out of 6 because there's 3 odd numbers. When I multiply fractions, I go straight across. 1 times 3 is 3. 4 times 6 gives me 24. And if I take 3 and divide by 24, my probability is approximately 0.125. Okay. All right, last problem. You spin a spinner and you roll a die. You would like the combined probability of rolling a 6 and spinning a blue section on the spinner to be 5%. How many blue sections do you need on a spinner with 10 sections? Okay, so two things that they want to happen. You want to roll a 6 and spin a blue section. Okay, so rolling a 6 would be 1 out of 6. And means I need to multiply. Spinning a blue section on a spinner. How many blue sections? Our spinner has 10 sections, so I'm going to put 10 down here and x on top. My combined probability needs to be 5%. 5% written as a decimal would be 0.05, so I'm going to set this equal to 0.05. Okay, multiplying fractions straight across. 1 times x gives me x. 6 times 10 gives me 60. So now I have x over 60 is equal to 0.05. How do I get x on a side by itself? Well, to get rid of that fraction, I need to multiply both sides by 60. What happens over here is they cancel out. So now I have x is equal to, if I take 0.05 times 60, I end up with 3. And really what they're asking is this would be 3 blue sections. Okay, assignment for today is going to be Unit 12, Day 2 worksheet. It's going to deal with compound probability and overlap.